In this clip, we're going to see how to use Excel to calculate the chi-square test when we're comparing sample proportions with population proportions. So let's take a look at our problem. Here we have three categories. We have buying, selling, and holding. And we have what we would expect in the population, what we expected, and then what we actually observed for each category. So we expect a third in each category, 0.33 for each of them. But what we see in the actual data in this example is 0.5 that actually sells, a quarter that buys, and a quarter that holds. So the first thing we do is the degrees of freedom. So that's the number of categories minus one. So we have these three categories minus one, giving us two degrees of freedom. So in Excel, we just enter the data in these cells, and then we can actually calculate the p-value. So Excel sort of does this backwards from how we might do it manually. So Excel calculates the p-value first before we calculate the statistic. But so if you're doing it by hand with the formulas, this will be backwards. But for Excel, that's perfectly fine to do it this way because of the values that they use. So we're going to use a little insert function here. And we're going to look for the chi-square test. Select it right there. Okay, so looking for the actual range. So the observed values is D2 to F2, so we include those. And then for the expected range, we include these three, D4 to F4. So what we expected. And that calculates the p-value, which is 0.939. So using our degrees of freedom and the p-value, we can have Excel calculate the chi-square statistic. So we're going to use the chi-inverse RT. So again, just go to the function, searching for the chi-square, with the inverse RT right there. Select. So we include the probability. So that's just looking for the p-value. So we can highlight that column there. And then for the degrees of freedom, highlight this column there, which is the degrees of freedom, which is why we just typed in that number, even though it's a simple number. Just makes this simple. And there we calculate the chi-square statistic, which is 0.125, which would give us, our answer for this problem.